Yes, students, all of you, welcome to the session. Continuation of our electronics concepts. I'm discussing chapter 3. With respect to chapter 3, I'm starting lecture 6. With respect to choppers, in the previous session that I given some practice questions and I given types of choppers based on quadrant operation, type A, type B, type C and type D and type E chopper. Okay. We have to see the two more concepts with respect to choppers. One is steady state analysis of type A chopper. Before starting that, how to remember this note. This is important for PSU's point of view. Type of converter, and quadrant operation. Quadrant operation. Or write type of converter, quadrant operation, and application. Quadrant operation and application. Okay. We know that single phase half wave rectifier, single phase semi converter, three phase half wave rectifier, three phase semi converter. All these converters operate in the first quadrant. These are operate in the first quadrant. Single phase half wave rectifier, single phase semi converter, three phase half wave rectifier, three phase. In first quadrant, which application you have to use? Forward motoring current. Forward motoring current. Next. Even one more is type A chopper. You also add the chopper na. Type A chopper is also operate in the first quadrant. All these are used for the forward motoring current. All these converters you have to use for forward motoring current. Okay. Next. What about type B chopper? Type B chopper is operated. Type B chopper only operated second quadrant. Remaining converters are not in second quadrant. No converter is operated in second quadrant. Only type B chopper is operating in the second quadrant. In second quadrant, which application you have to use? Forward braking. Use for forward. Next. Type C chopper. Only type C chopper operate in which quadrant? First and second quadrant. No another converter is operated in the first and second quadrant. It is used for forward motoring, forward braking. Next, fourth one. Single phase full wave rectifier, three phase full wave rectifier, and type D chopper. This is important. Single phase Fourier rectifier, three phase Fourier rectifier, type D chopper. All these converters are operating in which quadrant? First and fourth quadrant. This is used for forward motoring, reverse braking, that is a regenerative braking. Then last one is single phase dual converter, single phase dual converter, comma three phase dual converter, single phase dual converter, and three phase dual converter. Yes, and one more is type E choke. Type E choke. Okay. All these operate in which quadrants? Four quadrants, not fourth quadrant, four quadrants. Four quadrants it is operated. In four quadrants, it is used for four quadrants means it is used for which one, students? This is V naught, this is minus V naught, this is I naught, this is minus I. Forward motoring, forward braking, reverse motoring, reverse. This is important for PSUs who are preparing for PSUs one. This you have to remember. Next. With respect to types of choppers based on the quadrant operation, one more topic it is important. Steady state analysis of type A chopper. Steady state analysis of type A chopper. Type A chopper. Steady state analysis of type A chopper. Okay. Yeah, there is a large derivations of it, but I'm not giving all those derivations. Not required. Some observations are important. Let's consider the type A chopper. This is the type A chopper. In this type A chopper, there is a freewheeling diode. Let's consider with RLE load. Taking RLE. This is R. This is L. This is A. This chopper or switch. That the supply voltage is Vs. Friends, we know that chopper is on. Inductor storing the energy. Chopper is off. Inductor releasing the energy. If you take the chopper is on, this is freewheeling diode. Chopper is on, freewheeling diode is off. For the V naught, you can get Vs. Let us assume that the circuit we are operating in continuous mode. Chopper is on. If you open this one, this output voltage equal to supply voltage. Chopper is off. Freewheeling diode is on. If the freewheeling diode is on, load is short circuited. But the output? Zero. Output is zero. Let us assume that we are operating the circuit in continuous mode. Then here chopper is on, freewheeling diode is on. L storing the energy. L storing. Here what about the L? Releasing the energy. Okay. Then if you draw the waveform here, if chopper is on, V naught getting Vs. Drawing the V naught waveform. If the chopper is on, V naught equal to Vs. If chopper is off, V naught equal to 0. This is chopper on state. This chopper off state. Again chopper is on state. Clear? Then during chopper is on, current is changing from minima to maxima. This is the output voltage waveform. But this is applicable only in continuous loop for RLE loop. This is T. If you draw the output current waveform, friends. If you draw the output current waveform, during chopper is on state, whatever the current, inductor is storing the energy. No? If inductor is storing the energy, whatever the current, rising or falling, the current is rising. That it is a continuous mode. Yes, the current is changing from I minima to I maximum. Current is changing from I minima to I maximum. This waveform even buck regulator, boost regulator also again. Again current is changing from maxima to minima. Again minima to maximum. Then this is the average current. Average current. Okay. Similarly, if you draw the freewheeling diode current waveform, If you draw the freewheeling diode current waveform, during which time freewheeling diode is conducting? Chopper off time. Chopper is off, freewheeling diode is on. Na? Then this is the freewheeling diode current wave. Here there is no freewheeling diode current. Here freewheeling diode is conducting. Chopper is off means freewheeling diode is conducting. Again this is the switch current. Yeah, this is the freewheeling diode. During conduction of freewheeling diode, the inductor is releasing the energy. Okay. Yeah, this. But here by doing the steady state analysis, we have to find the I maxima and I minimum. Then using steady state, I'm not giving derivation direct. I'm writing. These formulas are important only for gate. Remaining observations are important PSU's point of view also. Using steady state analysis, you find the I maxima for RLE loop. We can get the I maxima equal to Vs by R into 1 minus e power minus T on by Ta by 1 minus e power minus T by Ta minus E by R. Yeah, this is the maximum current. By derivation only we can get this one. This is equal to minus E by. What is Ta here? Ta or it is also called tau A, time constant of RL circuit, that is L by R. This is the maximum current expression. By doing the steady state analysis for the chopper, we can get this expression. Then what the expression for I minimum? The expression for I minima equal to, that is Vs by R into e power T on by Ta minus 1 by e power T by Ta minus 1 minus E by R. This is I minima expression. Okay, this you have to remember. Once you know the maximum current and minimum current, friends, you have to find the peak to peak ripple load current. Peak to peak ripple current. How to express the peak to peak ripple current? Peak to peak load ripple current. Load ripple current. The peak to peak load ripple current delta I equal to I max minus I min. I max minus I. This is the peak to peak ripple current. Peak to peak. Then you have to simplify this one. Substitute I maxima value and substitute I minima value. By substituting I max and I minima, directly I'm writing. I'm not giving derivation. By substituting, you have to substitute the I maxima and I minima. I max and I minima. Then what we can get? We can get delta equal to one formula is Vs by R into one formula I'm writing Vs by R into 1 minus e power minus 0.5x by 1 plus e power minus 1. Derivation is there, not required. This is also equal to, this is in exponential form. You write in trigonometry, hyperbolic function, tan h of R by 4fl. This is the maximum ripple currents. This is maximum ripple. Vs by R into tan h of R. But students, we know that where these ripples are maximum. Type A chopper is also called which chopper? I told already. Type A chopper is also called which chopper? Step down chopper. Na? That is, in type A chopper or step down chopper, in type A chopper, ripples are maximum. Ripples are maximum. Maximum at D equal to 0.5. You find the what the condition for maximum ripple current? Maximum at D equal to 0.5, 0.5. That I already given in step down chopper also. Then this maximum ripple current is nearly equal to Vs by 4f. You please refer the, that is step down chopper, this formula I give. Then if ripples are maximum at D equal to 0.5, that is in type A chopper or step down chopper, if you draw the characteristics between ripple current and duty cycle, if you draw the characteristics between ripple current and duty cycles, this is D, this is delta I. Where the ripples are maximum, ripples are maximum at t equal to 0.5. At t equal to 0.5, ripples are maximum. What is this maximum ripple current? Ps by 4f1. What is the maximum duty cycle? 1. Then what is the observation here, friends? For 0 less than t less than 0.5. That means up to duty cycle 0.5, up to duty cycle 0.5. If duty cycle is increases, what are the ripples also increases? Up to 0.5, if duty cycle is increases, ripples also increases. What about 0.5 to 1, students? What is the 0.5 to 1? If duty cycle is
D
increases,
increases, ripple decreases.
ripples are decreases. For 0.5 less than t less than 1, if duty cycle is increases, these observations are important even PSU's point of view also. Then ripple currents are decreases. It is important observation. But ripples are maximum at duty cycle equal 0.5. Next. And one more important observation that you have to concentrate, friends. With what is the maximum value of ripple current? Maximum value of ripple current equal to Vs by 4Fl. Okay. We know this, if load inductance is increases, if load inductance or if L is, if inductance is increased, maybe filter inductance, load inductance, whatever maybe, if inductance is increases, if inductance L is increases, what the ripples reduces. That is, by increasing the inductance, we can reduce the ripples. And there is one more method is there, without increasing inductance, without increasing L, resistance, without increasing L to reduce ripples. What you have to do? Without increasing L, one method is L is increases, ripples are reduces. Without increasing L to reduce ripple, to reduce ripple. One method is if frequency is increases, ripples are reduces. Na, to reduce ripple, frequency must be increases. To reduce ripple, frequency is increases. One method you have to reduce the ripple is to reduce ripple frequency increase. That is, chopper is operated at a chopper is operated at a high frequency or low frequency, high frequency, operated at a high frequency. Okay, this concept you have to apply. Without increasing L to reduce the ripples, chopper must be operated at a high frequency. Next, here I am giving some note points, but there is a derivation is there, but I am not giving derivation. Simply remember. The average switch or thyristor current is maximum at a duty cycle. That is, this switch may be thyristor also. We have to use the any device is used as a switch now. Then at what is the condition for? That is at what duty cycle? At what duty cycle the current through the switch is maximum. The average current through the switch is maximum. Yes, students. The average current through the switch in the circuit, the average current through the switch is maximum when that average current through the switch is maximum at a duty cycle of at D equal to E by 2 Vs. By derivation we get. At what duty cycle the average current to the switch is maximum. Next, the maximum average switch current. What is that value? The maximum, once you know the condition, the maximum average switch current. We have to calculate maximum average switch current. Then what is the maximum average switch current? The maximum value of average switch current. The maximum value of average switch current. That is maximum average switch current equal to, by derivation only you can get. This is equal to E square by 4 VSR. E square by 4 VSR. Next, the RMS value of freewheeling diode current is maximum. RMS value of freewheeling diode current is maximum. Freewheeling diode current is RMS freewheeling diode, not average freewheeling current. RMS freewheeling diode current is maximum at D equal, this also by derivation we can get, at D equal to 1 by 3 into 1 by 3 into 2 plus E by Vs. At this duty cycle, RMS value of freewheeling diode current is maximum. Then what is that maximum value of RMS freewheeling diode current? That value is how much? Maximum value of, what is that value? Maximum value of RMS freewheeling diode current. Maximum value of RMS freewheeling diode current. What is that value? Maximum value of RMS freewheeling diode current equal to, that is IF WDR max is equal to, by derivation we can get 0.3849, 0.3849, important for gate point of view, Vs by R into 1 minus E by Vs whole to the power of 3 by 2. This is the maximum value of RMS freewheeling diode current. Can anybody tell what is the shape of the freewheeling diode current waveform? Even this point is applicable for buck regulator also. What is the shape of the freewheeling diode current waveform? This is the freewheeling diode current wave shape now. The freewheeling diode current wave shape is trapezoidal.
Trapezoidal.
Yeah. Yeah. Freewheeling diode. The shape of the freewheeling diode current waveform is trapezoidal. The shape of the freewheeling diode current waveform is freewheeling diode current waveform is trapezoidal. Trapezoidal. The freewheeling diode current waveform is trapezoidal. Clear. Next. One more important topic with respect to type A chopper itself. Fourier analysis of type A chopper. This also questions are framing. Important for both gate and PSU's point. Fourier analysis of type A chopper. Type A chopper. What is the Fourier analysis of type A chopper? Let's consider the output voltage waveform of type A chopper that is in continuous mode. Let's consider the Fourier analysis of type A chopper. Then let's consider output. You know output voltage waveform. In type A chopper, this is the output voltage waveform. This V naught. This is how much? Vs. This is Vs. This is T on. T on is nothing but a dt. And chopper is off. This is T. Then this is the output. This output voltage waveform is pulse weighting DC. It is a pulse weighting DC now. Then if it is a pulse weighting DC, if you apply the Fourier analysis for this waveform, this is the T on. T on is nothing but a dt. T on is nothing but a dt. This is chopper on. This is chopper is off. This is the T on. By applying Fourier analysis, that is, if Fourier analysis applied for this waveform, if Fourier analysis is applied, you know how to apply Fourier analysis. You have to calculate A naught, An and Bn values, then substitute that A naught, An and Bn values in the function. Yeah, directly I am writing. If Fourier analysis is applied, if Fourier analysis is applied, what the output voltage? The instantaneous output voltage is equal to, by derivation we can get this one, dVs summation n equal to 1 to up to infinity 2 Vs by n pi sin n pi d. Important formula, sin n pi d sin n omega t plus theta. Sin n omega t plus theta. That is, by applying the Fourier series, we can get this one. But what is theta n here? Yeah, that is theta n equal to, you have to calculate tan inverse. Tan inverse. This is theta n. Theta n equal to, how to calculate tan inverse cos n pi by cos n pi d by sin n. Cos n pi d by sin n. Then in this you have to write what is the maximum value of nth harmonic output. Same concept, how to write the formulas I already explained in the rectifiers, full wave rectifier. Like that you can write the formulas. In this total function, in the total representation, which is the maximum value, students? 2 Vs by n pi sin n pi d. This is the maximum value. But because this is the function, this amplitude is the maximum value. Na? Then what is the maximum value of nth harmonic output voltage? Important formulas. Maximum value of nth harmonic output. What is the maximum value of nth harmonic output voltage? That is V naught Nm equal to, except function remaining term is the maximum value. That is a 2 Vs by n pi into sin n pi d. Okay, this is one. What is the maximum value of nth harmonic output voltage? What is the RMS value of nth harmonic output voltage, friends? Yes, RMS value of nth harmonic output. Nth harmonic output. Can you tell what the RMS value? How to get RMS value of nth harmonic output? Maximum value by root 2. No? Maximum value by root. This RMS value of maximum value by root. Then by simplifying this, root 2 Vs by n pi sin n pi sin n. But very important is RMS value of fundamental. How to calculate RMS value of fundamental? To calculate RMS value of fundamental, substitute n equal to 1. Then RMS value of fundamental output equal to RMS value of fundamental. Important for gate exam. RMS value of fundamental output. If you write RMS value of fundamental output n equal to 1, that is root 2 Vs by pi into sin pi d. Root 2 Vs by pi into. This is the RMS value of fundamental in a type HO, sin pi. But here the question is, output consists of harmonics. To eliminate the nth order harmonics, you have to operate the chopper at what duty cycle? Then this is important. To eliminate nth order harmonic, you are finding the condition. To eliminate nth order harmonic, at what duty cycle it is preferred? To eliminate nth order harmonic, you have to equate sin n pi d equal to 0 to get the condition. Sin n pi d 0 means what is n pi d equal to pi? Then pi sin 180 0 na. What is d equal to 1 by? That is to eliminate the nth order harmonic. What is the duty cycle you have to maintain? This is very important formula. Even for PSUs, it is important. So, for example, if the question is asked like this, to eliminate fifth order harmonic, to eliminate, or you have to take a fifth order harmonic, or to eliminate the second order harmonic, what is the duty cycle to eliminate fifth order harmonic?
1 by 5.
1 by 5. That is the correct. Like this, you have to calculate d equal to 1 by 5. Yeah, that is the calculation of 1 by 5. That is. This is very important. That is generalized for 1 by 5 duty cycle. Yes. For example, if the question is asked like this one model of question already framed in computer exam. In type A chopper, in type A chopper, in type A chopper, if the output does not consist of fifth order harmonic, if the output does not consist of fifth order harmonic, fifth order harmonic, fifth order harmonic. Calculate form factor and ripple factor. Calculate form factor and ripple factor. Yes. It is a type A chopper. Na type A chopper is also called step down chopper. Then form factor equal to V naught RMS by Vs. Na. In step down chopper or type A chopper, these formulas are applicable. Root 2 Vs by dVs 1 by root d. Then what it is eliminator? Output does not consist of fifth order. If output not consist of, if output not consist of fifth order, na. If output not consist of fifth order, which is eliminated, fifth order is eliminated. If the fifth order is eliminated, what the duty cycle? 1 by 5. Now substitute here. 1 by square root 1 by 5 we get root 5. That is the form factor. Form factor equal to, can you tell what are the ripple factor, students? Ripple factor equal to square root form factor square minus 1 is a relation between ripple factor and form factor. That is 5 minus 1. If you square this root, root square will be cancelled, 5 minus 1, that is root 4. Then what is the ripple factor? Ripple factor equal to 2, then form factor equal to root 5. That is. Sir, how you got this root dvs, sir? You please check the step down chop. I given already. Okay. Like this model may expect that you have to consider. And one more point you have to remember, students. Here I calculated only voltages. If it is asked what is the nth order harmonic current, nth order harmonic current equal to nth order harmonic voltage by Zn. And in general, for purely inductive load, nth order harmonic current is 1 by n square. Nth order harmonic current equal to 1 by n square. Inversely proportional to 1 by n square. But no need of proof, leave it. Yeah, these are the points you have to remember. With respect to who are preparing for PSUs, this is important and this is important to eliminate nth order harmonic duty cycle. But who are preparing for gate point of view, these formulas are important. What is the maximum value of nth harmonic output? What is the RMS value of nth harmonic? What is the RMS value of fundamental? These formulas are important. That you have to consider. Next. But I written up to now whatever the formulas with assumption of continuous mode. Without current zero. Here you see now waveform. Without current zero, current is applied to the load. That is the continuous mode. See, for example, same RLE load, how to write the formula in discontinuous mode? For RLE load case, how to write the formula in discontinuous mode? That you have to see. What I am writing. Let if type A chopper with RLE load is operating in discontinuous mode. If type A chopper with RLE load operating in discontinuous mode, operating in discontinuous mode, operating in discontinuous mode. Type A chopper with RLE load operating in discontinuous mode, then how you can get the expression for, say, listen, students. Once again, I'm drawing the type A chopper. Let RLE load. This is R, this is L, this is E. Okay. Let the supply voltage is Vs. Chopper or switch. This is freewheel. If you draw the current waveform, if you draw the voltage and current waveform, this is the case of discontinuous mode. I'm drawing the discontinuous mode waveform. Yes, let 0 to T on chopper is on. Next chopper is off. Chopper is off. This is chopper on. This is chopper off. Now I'm drawing the current waveform separately. This is current waveform. Yes, friends. And voltage waveform also I'm drawing some output voltage wave. Yes, friends. Concentrate. During chopper is on, current is, it is a discontinuous mode. Discontinuous mode you start from 0. Current is rising. During chopper is on, diode is off state. What is V naught equal to? If you take V naught, this V naught equal to Vs. During chopper is on, V naught equal to Vs. Okay. Chopper is on, diode is off state. Then output voltage equal to source voltage. Output voltage equal to source voltage. Now you tell me, if the chopper is off, who is on? Diode is on. If the diode is on, inductor releasing the energy now. Inductor releasing the energy, let assume that it is a discontinuous mode now. If it is a discontinuous mode, before completing one time period, current is zero. Now here who is conducting? Chopper is conducting. Here who is conducting? Freewheeling diode is conducting. Now up to this time, students, up to this time, what is the voltage across the load? Zero. Why? Voltage across the load is zero because the load is short circuited if the freewheeling diode is conducting. Now after already chopper is on and it is turn off, freewheeling diode is also off. Now chopper is off state, freewheeling diode is also off state. Both are off state. During conduction of freewheeling diode, voltage zero. Why? Because it is short circuit. Now what I am telling, chopper is off state. This is open. Freewheeling diode is also off state. Then what is the output voltage? That output consists of battery. Because it's active load now, that output consists of the battery. Like this we can get the shape. Clear, friends? During chopper is on, V naught equal to Vs. Chopper is off, freewheeling diode is conducting, output 0. Next, no device is on. Chopper is off state, freewheeling diode is also off state. Then what the output voltage equal to? Battery voltage. Output voltage equal to battery voltage. Now for this case, how to write the average output voltage? Here during chopper is on, let the current is rising, let this time is TR. During freewheeling diode is on, let this time is falling, current is falling, the falling time. Here no device is conducting, no device T naught, no device is if no device is conducting, the output voltage equal to battery voltage. Now can you write what the average output voltage, friends? For this type of waveform, what is the average output voltage? How to write average output voltage? V naught equal to, during TR time, output voltage is Vs. That is Vs into TR plus. During TF time, this is during TF time now. Freewheeling diode is connecting. Freewheeling diode conducting, output equal to 0 because load is short circuited. That is TF into 0 plus. During, this is which time, students? T naught time. During T naught time, what is the output voltage equal to E? That is E into T on by. Then what is the total time of operation? TR plus TF plus T naught in one cycle. Then average output voltage equal, because they say during TF time voltage 0, then Vs into TR plus E into T naught by TR plus TF plus. Sir, why you taken TR, TF and T naught? Here current rising and falling, there is no current. That's why I taken notations TR plus TF plus T naught. This is the average of. Clear? How to write the formula in discontinuous? Direct formula is asking computers. Yes. This is about how to write the formula in discontinuous mode. Next. Then we have to take one more important topic with respect to choppers: voltage control techniques in choppers. Voltage control techniques in choppers. Techniques in choppers. Yes. The voltage control techniques in choppers broadly classified into two types. One is, what are the voltage control techniques? One is time ratio control techniques. Time ratio control technique. that is TR. Another one is current limit control. Current limit control means by controlling the current between minimum and maximum, output is controlled. Correct. Then what is the time ratio control? Time ratio control. These time ratio control techniques are again two types. Friends, we know that what is V naught equal to dVs? In a step down chopper or buck regulator, V naught equal dVs. How to write duty cycle? T on by T into Vs. That is T on into F into Vs. That is how to control this output voltage. We can control the output voltage by controlling the on period, by controlling the frequency. Then based on this time ratio control techniques are two types. One is, yes friends, constant frequency control. Constant frequency control. Frequency control. What is the another name for this one? The constant frequency control, or it is also called pulse width modulation control. Pulse width modulation control. What do you mean by constant frequency control, friends? The name itself indicates na. Keeping frequencies constant by controlling T on, we can control the output voltage. That is, we can throughout operation, we can keep the frequencies constant. Keeping frequency equal to constant. Yes, friends. Keeping frequency is constant by controlling T on, output voltage is controlled. By controlling T on, by controlling T on, output is controlled. That is called constant frequency control. But what is T on? T on is also called pulse width. Na? T on is pulse width we are controlling. That's why, hence it is also called pulse width modulation. Hence it is also called pulse width modulation. PW. Why the name is given as a pulse width modulation? Keeping frequency constant throughout operation, we can maintain the frequencies constant by controlling TR. Output is controlled. That's why it is called constant. But it is more preferable as compared to variable frequency control. It is more preferable. That is pulse width modulation or constant frequency control. It is more preferable as compared to PW, as compared to frequency modulation. Frequency FM control. FM in the sense frequency modulation control. Next, the second one is that one, frequency modulation. The second method is variable frequency control. Variable frequency control or frequency modulation. For these waveforms also there, but I am not giving, not required. Variable frequency control. Or it is also called frequency modulation technique. Or frequency modulation technique. Variable frequency control, it is also called frequency modulation. That is, what do you mean by variable frequency control or frequency modulation? Keeping either T on or T off is constant. Either T on or T off. We can keep the either T on or T off is constant. It is a variable frequency, na? By controlling frequency, output is controlled. That you see in this formula. By controlling frequency, output is controlled. By controlling frequency, output is controlled. Output is controlled. Then it is called frequency modulation technique. But this method is not more, that is not preferable as compared to PW. Why? If you vary the frequency for very large value, one is it causes the interference effect and large filter is also required. If you vary the frequency for very large value, it causes the interference effect and large filter required. That's why it is not required. Then last one is current limit control. This all of you well know so many times that waveforms also I given. Even type A chopper also I given. What do you mean by
Sir,
current limit control?
sir,
By yes, tell me.
sir, 1 minute. Kindly explain the reason, sir. Why we are not preferring this frequency modulation control technique?
See, we are varying the frequency now. See, for
Yes, sir.
example, if you have to increase the output voltage, we have to increase the frequency. If you increase the frequency for very large value, high frequencies may cause us the interference effect.
Okay, sir. Okay.
Interference effect. That is one problem. If the frequency is increased for large value, a large filter is also in there. A large filter is also required. Large filter required. Okay, because of these drawbacks, it is not preferred.
Okay, sir.
What do you mean by current limit control? Current limit control is nothing but by controlling the current between minima and maxima, output is controlled. By controlling current between minima and maxima. In minima and maxima, that is minimum and maximum value. In minimum and maximum value, output is controlled. Then if you control the current between minimum and maximum value, then average output current equal to maxima plus, based on this problem also I already solved, I maxima plus I minima by 2. That you have constant. That is about the, for this case there is a waveforms are there. For this case also there is a waveforms are there. You it is not required. Leave it. But point to remember, keeping frequency T on is variable, constant frequency. Keeping either T on or T off, not both are constant, frequency will not change. Either T on is constant or T off is constant. If one is constant, another is variable, then only frequency will change. Then by controlling frequency, output is controlled. You know that T equal to T on plus T off now. This is equal to 1 by F. Keeping T on is constant, T off is variable, T is variable, frequency is also variable. Keeping T off is constant, T on is variable, T is variable, frequency is variable. That is a meaning. Okay, this is about the voltage control techniques in choppers. And this node point also you have to concentrate. In general, in choppers, if type of chopper is not mentioned, you have to take like this one. Continuous mode, continuous. For theory question, mainly this is important for PSUs. Continuous mode, discontinuous mode. Continuous mode, discontinuous. When will your TNPSC exam?
Sir, it is next month, sir. Next month, 14th, it is starting.
Are you preparing for TNPSC or GATE? Both.
Both, sir.
This is important mainly for PSU's point of view, and even GATE point of view not important. Already these questions are there in ESC exam. Okay. See, in choppers, in general, load current, if you take load current, you know already based how to say that it is a continuous mode or a discontinuous mode based on the load current only. If load current is discontinuous, we can say that it is a discontinuous mode. If the load current is continuous, then we can say that it is a continuous mode. That means in continuous mode, load current is continuous. In discontinuous mode, load current is discontinuous. Load current is continuous. This no need to remember. All of you know this one. How to say that it is a continuous mode or discontinuous mode? In discontinuous mode, load current is discontinuous. In continuous mode, load current is continuous. Okay. That no need to remember. Next. What about the load voltage? We know that in choppers always load voltage is controlled. We are getting pulsating DC. That is variable DC. Variable DC means it is not a continuous voltage. That's why always load voltage is discontinuous. It may be continuous mode or discontinuous mode. Discontinuous in the sense not constant voltage we are getting now. Variable DC we are getting. That is load voltage is discontinuous. Here also discontinuous. Discontinuous. In a continuous mode, load voltage is discontinuous. In discontinuous mode also load voltage is discontinuous because it is a variable voltage. Next. Can anybody tell what is the supply voltage? In a choppers,
It
what about
is
the supply voltage?
continuous, sir.
Yes, very good. We are giving constant voltage now. We are giving constant voltage. That's why it is a constant voltage. That is the source voltage is always continuous. Source voltage is, it may be continuous mode or discontinuous mode. We are giving constant supply. But chopper on, chopper off, connected, disconnected. See, for example, this is supply, chopper on, chopper off. It is connected, disconnected. Connected, disconnected means only the switch is on and off. Based on that, current will change. But I'm not switch off, I'm not power, that is, this power is not switch off. I'm not switch off the supply. I'm controlling only on and off of the switch. Now, that's why constantly I'm giving. Supply, I'm applying the constant. That's why it is a continuous. Then one more is source current. This is supply voltage now. Supply voltage or it is also called source voltage. We have to take the source voltage. Source voltage. Then next source current. If you take the source current is, take this one. This is the one chopper. Like this is the type A chopper. Type A chopper. Now. Chopper on, then source current is passing through the load. Chopper off, load current will circulate through freewheeling. Then chopper is on, then only source current is exists. Chopper is off, there is no source current. That's why it is always discontinuous. Continuous mode, discontinuous. Discontinuous mode also discontinuous. Except one chopper. If type of chopper is not given, like this only you take. But specially it is given in boost regulator or in step-up chopper. In step-up chopper or boost regulator. In step-up chopper or boost regulator. Chopper or boost regulator. Source current is continuous in both continuous mode, discontinuous. In both continuous mode and discontinuous. The reason I will explain. Generally, if type of chopper is not given, you take like this one. In both continuous mode and discontinuous. This is possible only in which case? Step-up chopper. You know step-up chopper circuit, that is also called boost regulator. Step-up chopper is also called boost regulator. If you, how to identify boost regulator? Inductor is at a source side. This is boost regulator. Correct? This is the boost regulator. You see, in step-up chopper, chopper on, chopper off. Chopper on, chopper off. If on or off, always the source is connected now. Source is always connected means always load current is, source current is exist now. But if it is a step down chopper, because switch is in series with source. That's why on and off, if it is on, then only source current. If it is off, no source current. If it is a step up chopper, it may be on and off. Always the current is exist. Always. If on, current will flow like this. If off, chopper is off, current will flow like this. Always source supplying the current. Because of that reason only, if it is mentioned step up chopper, source current is continuous both in continuous mode and discontinuous mode. But if the name of chopper is not given, you take always discontinuous. Friends, this no need to remember. Why? Because based on the load current only, you say that continuous or discontinuous. Continuous mode, continuous, discontinuous. This load voltage always variable na, that's why it is a discontinuous. Source voltage always constant na, that's why it is a continuous. Source current is connected, disconnected, connected, disconnected na, that's why it is a disconnect, discontinuous. Continuous mode, discontinuous. and even discontinuous mode also the source current is discontinuous. This is about types of choppers based on the quadrant operation and also steady state analysis of type A chopper students. Last one topic is there in choppers. Tomorrow it will finish. Okay, that is the types of choppers based on the commutation. But if you have to understand this topic, already in chapter 1, lecture 14, all the PPT I shared students. Chapter 1, lecture 14, I given concept of LC circuit. For next tomorrow class, today you please go through that topic once again. Chapter 1, lecture 14. I shared the PPT na chapter 1, lecture 14, where I explain the concept of LC circuit. I already given commutation methods. In commutation method, I explained some introduction where I given the class A commutation and class F commutation in detail. But I am not explain B, C, D, E commutation. Na? That will be covered in the choppers. In the next, that is the last topic. But in that only voltage commutated chopper and current commutated chopper is important. But some PSUs, simple questions they are framing for load commutated chopper. So, okay, that you will see tomorrow class. But for tomorrow who are attending, you please go through the whatever the commutation methods I explained. That is concept of LC circuit you have. Lecture 14, lecture 15, you please refer. Chapter 1, lecture 14 and lecture 15. Okay, thank you. English. Any doubt?
No, sir.
Thank you.